Okay, so we're going to review how to predict and balance reactions as another intro to chem, but this does carry on throughout grade 11, grade 12, and even into university. We always need to be good at predicting and balancing. So the first reaction we reviewed last week was composition, and taking a look here, we have Mg coming together with oxygen, and when that comes together, Mg has a charge of +2, oxygen has a charge of -2. So when we swap and drop, and if we wrote this in steps, MgO2, because it's an ionic compound, we can reduce if we have a common, I want to say charge, but if we have a common number there. So this would be just MgO. So I'm going to write this down. That is our product, MgO. And ionic compounds like to be solid at room temperature unless we see something that tells us otherwise. Now we need to balance. So as of right now, if I looked at what I have on each side, I have magnesium and I have oxygen. On the left-hand side, as a reactant, if you don't see any numbers here, we know we only have one magnesium. And on the right-hand side, same thing. We only have one. For oxygen, because of this 2, we know we have 2. And then over here still, no numbers, we know it's going to be a 1. So magnesium right now looks balanced. Oxygen is not. So to balance out oxygen, we are going to put a 2 in front of MgO, which means we have 2 Mg and 2 O. So now the oxygen gets changed to 2, and this magnesium also gets changed to 2. This is on our product side. But now our magnesium is not balanced. So to balance that out, we'll put a 2 here, and now everything is happy. We have the same amount on each side. So that one is for composition. Our next one is decomposition. So if I'm looking at decomposition, I'm going to break this up into my mercury ion, or not ion, atom, which is liquid at room temperature, and sulfur. Now sulfur can get a little bit tricky because sulfur, when it occurs by itself, has an 8. So unlike our diatomic elements like oxygen, hydrogen, things like that, where it's always in 2s, sulfur is one you just have to remember, and it's going to be S8. And I believe that one is also a solid at room temperature. So from here now, we want to go ahead and balance. We can see right away that our sulfur has only 1 on the left-hand side and 8 on the right. So let's balance that by putting an 8 in front of the HGS. And that now makes 8 Hg as well. So I'll put an 8 there. So now, again, if we look at our reactants and our products, we have Hg, we have sulfur, we have Hg, we have sulfur. So now with that 8 in front, that means I had 8 of each. And on my product side, I have 8 Hg and 8 sulfur. So everything is balanced. Now, if you like making this chart, go right ahead. But as you get faster, you won't need it. So looking at a single replacement reaction, we have chlorine gas, so notice that 2 because it's diatomic, and NaI, so sodium iodide. When it is single replacement, if the element that is alone is a gas, it is going to swap with the gas. So now I'm going to have sodium chloride come together, and we know sodium has a charge of +1, chlorine -1. So when we swap and drop, you only need 1 of each. So you'll have NaCl, and this one is AQ. You do want to check the data booklet now, whether you have a solid or aqueous state. So just looking at page 6, if you have the data booklet from Calgary, Alberta. And then iodine is diatomic. So when you write that alone, it is a 2, and this is a gas. Now if we went ahead and balanced this, we see chlorine, there's a 2 here. So I'm going to put a 2 in front of the NaCl. So that means now I have 2 sodium and 2 chlorine. So now to balance out sodium, I'll put a 2 here. So now on the left-hand side, I have 2 sodium and 2 iodine, and I have 2 iodine on the right. So now that one is balanced. So here again, we want to be good at predicting our products based on the type of reaction we see, and then balancing when we're done. Okay, so moving on from this one, double replacement. So I have PbNO32 and Ki. So if it is double replacement, your metals are going to switch places, coming up with 2 brand new products. So now if potassium is taking the place, potassium has a charge of +1, and nitrate has a charge of -1. So we just need 1 of each. So this would be K and then NO3. I don't need brackets because I have one of each. If brackets help you, put the bracket, then you know there's only one there. If that doesn't matter to you, don't worry about it. And then this one would be aqueous. And then the next one, you have lead coming together with iodine. Now, lead is multivalent, so your possible charges on lead, I'm just going to double check, is going to be +2. Now, I just want to make sure I'm not giving the wrong one for the second one, and +4. So looking at this 2 over here, and the fact that we know nitrate is -1, we had to use +2 for our swap and drop. So I know I'm doing Pb +2 and iodine, and now swap and drop, I have PbI2. And I believe that's a solid at room temperature. Again, I'm just focusing more on predicting. I don't have my data booklet with me. So if that's wrong, I'm sorry, but let's focus more on predicting the products and balancing when we're done. Now, if you do have some polyatomic ions, like the nitrate ion, keep it together, right? We want to count it as one. So on my reactant side, I have 2 of the nitrate ions, and on my product side, I only have 1. So I'm going to put a 2 here to balance that out. That also made 2 potassium, so I'll put a 2 in front of the Ki. And then from there, everything else is balanced. We have 1 lead on each side, and this 2 in front means there's also 2 iodine, and there's 2 iodine there. So that's all balanced. So this one is done. Now the next one is an acid with a base. So this is still double replacement, but it's a special type. It's acid-base neutralization. So when that happens, you know you have an acid because in this case starts with H, our base ends in OH. You'll always get a salt and water. Now, if you don't remember that, we still know we're just going to swap our metals, and hydrogen is special because it can act like a metal. So here now, sodium comes together with chlorine. They both have a charge of 1, so we just need 1 of each, and that will stay as an aqueous state. And then we have H coming together with OH, and that would be HOH, or you could just rewrite that as water. And that is an acid-base neutralization because you will always get your product salt and water. Now, when you're done that, you want to go ahead and balance. And this one is actually already balanced. We don't need to add in any more coefficients. So this one is also done. The last type of reaction we want to review is hydrocarbon combustion. And in the beginning or your intro levels of chemistry, you only worry about complete combustion, where your products will always be carbon dioxide and water. So as long as you can identify that you have a hydrocarbon in the presence of oxygen, you would know to write carbon dioxide and water as your products. Then you want to go ahead and balance it. So when I teach balancing, I always say to start with hydrogen. So for instance, on my left-hand side, I have 4 hydrogen, and on my right, I only have 2. So I am going to put a 2 here. And I believe now hydrogen's good. Carbon, on the other hand, I have 1 on the left, 1 on the right, so that is also good. And my last one is oxygen. So when it comes to oxygen on the product side, it is coming from 2 places. You have 2 from the carbon dioxide, and now with this 2 in front of the water means you also have 2 oxygen coming from the water. So that's 4 oxygen altogether. All right, let's start 4 oxygen. And then to make 4 on the left, we're going to just add a 2, and now that's balanced. So again, with combustion reactions, my steps that I like is to start with hydrogen, and then move on to carbon, and last do oxygen. And now I have an extra step here, and that is when you do start with hydrogen, but to balance it, you would have to add in a odd number. So let me show you what I mean here. So same thing, I know I have a hydrocarbon and oxygen, so that's going to be carbon dioxide and water as my products. Now, when I go to start with hydrogen, if I went to go put a 3 here and I continue to balance, nothing is going to work out unless I use a fraction. Now, in the intro to chemistry courses, we don't use fractions, we only use whole numbers. So then I add this step about hydrogen. If it is odd, then double your value. So instead of writing a 3, I'm going to double that and write a 6. Now, when I do that, I now have 12 hydrogens on my product side. So I'm going to put a 2 in front of the C2H6 because now I also have 12 hydrogens on my reactant side. That also does affect the carbon. I'll have 4 in total on my reactant side, so I'll put a 4 here. So again, I start with hydrogen. It was odd, so I doubled it. I moved on to carbon, and then lastly, balance out your oxygen. So recognizing it's coming from 2 places. From the carbon dioxide, you have 8, and from the water, you have 6. So a total of 14. So to balance that out, I'm going to put a 7 here. So then we are done. Hydrocarbon combustion is usually one of the harder ones, so try to remember these steps. As always, I hope you found this helpful. If you did, please subscribe, and if there's any other video I can ever do, just let me know. Thanks for watching.